The deep dive is back, and today we're tackling a digital friction point I think every academic writer knows way too well.
Oh, yeah.
You have this incredible LLM, this powerful AI on a server somewhere, and it's ready to help you write. But, how do you actually use it?
Right.
9 times out of 10, what happens is you copy a paragraph, you paste it into some external chatbot window, you wait for a suggestion.
And then you copy that back.
Exactly. And you just pray. The formatting doesn't completely break your document structure, especially if you're in something complex like LaTeX.
That copy and paste loop, it's more than just inefficient. In the academic world, it's corrosive.
Corrosive, how so?
You lose all the context. The structural context of your document is gone. Your revision history is a mess, and you spend more time managing windows than actually refining your argument.
That gap.
That's it. The physical and technical space between your editor and your AI. That is exactly what the system we're looking at today is built to eliminate.
And our sources introduce this system as PaperDebugger. It's a fascinating approach because it doesn't just sit next to your editor.
No, it lives inside it.
It's an in-editor, multi-agent assistant built right into Overleaf, which, for our listeners, is a hugely popular LaTeX editor in the research world.
They're essentially putting the brain of the AI directly into the document, right where the writing happens.
So our mission for you, the listener, is to really unpack the architecture that lets this AI perform these genuinely agentic, context-aware operations right inside your document.
And when we say agentic, we're not just talking about a better chatbot, are we?
No. What does that functionally mean for a writer? What is agentic?
It means the AI can act on its own to complete a multi-step task. It's not just a single answer to a single prompt.
Oh.
You give it a high-level command like, strengthen this related work section.
And it just goes.
And the agent handles all the subtasks. It does the critique, the research lookup, the drafting, the formatting, and then a final validation step. It's like an independent, sophisticated worker that's built for academic depth.
So this is way more than a novelty. It feels like a foundational shift. And the sources point to 3 key breakthroughs that make PaperDebugger really stand out.
The first one is the most obvious. It's that true in-editor integration with Overleaf. That alone kills the copy-paste friction.
Right.
Second, they've designed a really scalable multi-agent architecture. It's driven by Kubernetes, which is critical for handling all those complex parallel reasoning tasks without a huge delay.
And the third piece, which is what gives me confidence that this is actually a viable solution.
The real-world data.
Yes,
Yeah.
The evidence of real-world usability and sustained adoption. They didn't just build it. The analytics show researchers are sticking with it. They're using it again and again. That's a huge validation.
It absolutely is.
Yeah. Okay, let's unpack that integration, because that's really where this whole thing starts to solve the core user problem. Current LLM tools, even the good ones, they often fail to interact deeply with the document's internal state.
Right. The structure, the revision history, the suggestions just feel sort of ephemeral, They disappear once you close the window.
And the source materials, they're very clear on this. They call achieving this deep in-editor interaction technically non-trivial.
It's a great phrase.
Yeah.
Because it's true. This isn't just about pasting a chatbot window next to your text. You're operating in a live, version-controlled environment. It's a whole different ballgame.
So what's the big technical hurdle there? Why is it so hard?
You need a few things working perfectly all at once. The biggest one is reliable, real-time, bidirectional synchronization.
Bidirectional.
Meaning if you, the author, make a change in Overleaf, the AI has to see it instantly. That way the AI never suggests a change based on an old version of the document. Then you need secure state management and, crucially, a way to generate patches.
Bidirectional synchronization. That sounds super technical, but the impact on the user is just massive, isn't it?
Huge.
You never have to worry that the AI is, working on a ghost version of your document.
Precisely. And PaperDebugger gets this done by implementing a Chrome-approved extension. This extension injects these lightweight UI components, a floating panel, some inline buttons, right into the Overleaf interface.
And when you select text.
The extension captures that state and uses gRPC to talk to this really sophisticated backend.
So the result of all that is that the critique, the refinement, it all happens in context. It's inline, it's tied directly to your document structure.
And that continuity is preserved because the system doesn't just dump a block of new text on you,
Yeah.
it generates what they call patch-based edits.
Now, this seems like the key for professional use.
It is. You don't get a suggested paragraph.
Yeah.
You get a validated diff. It shows you exactly what was taken out and what was put in, and you can accept it with one click.
Which gives you, as they say, deterministic, traceable editing.
Exactly. You have a perfect record of what the AI did right inside your normal version history. All the guesswork is gone.
So that seamless front end is only possible because of what's happening under the hood. Let's shift gears and look at that architecture, because this is where the scalability and reliability really come from.
Right. The system is all built around stability and extensibility. The central nervous system is what they call the back-end layer.
And that's handling things like user logins, session state.
Authentication, session state, and all the workflow routing. And this entire layer is deployed on Kubernetes.
Kubernetes. I mean,
Yeah.
you usually associate that with running the biggest tech services in the world. Isn't that a bit of overkill for a writing tool?
You'd think so, but it's necessary because of what the tasks are. Remember, this isn't just a grammar checker.
Right.
When an author asks the system to do something like deep research or analyze a full 30-page paper, that one request has to be broken down into dozens of smaller queries.
And those need to run at the same time.
Exactly. You need simultaneous access to LLMs, to retrieval engines, to validation tools.
So Kubernetes lets them just spin up specialized worker pods on the fly to handle those bursts of parallel work.
Which keeps the whole thing fast and concurrent, so your editor never lags. And that foundation supports their agent layer, which is the real execution engine.
And that agent layer, it actually has two different modes of execution, right? It seems like they're trying to balance speed with depth.
That's a smart way to put it. First, you have your prompt template agents.
The lightweight ones.
Very lightweight. Single-shot LLM calls. They're for your low-latency tasks, like, polishing a sentence or fixing grammar. You need those results in a second or two.
But then for the heavy lifting.
That's where the workflow-based agents come in. These are these declarative workflows that coordinate multiple steps.
Like a sequence of events.
Exactly. An LLM call, then maybe a semantic search, then a pedantic validation step, and then the final text generation. These are for the big jobs, like finding related papers or doing a deep structural review.
So what keeps these complex workflow agents from going off the rails? There's a special communication framework. They call it XtraMCP.
XtraMCP is the crucial middle layer. It's a lightweight framework that exposes a set of thoroughly validated tools to the agents.
And in a field like research, where LLM hallucinations are a disaster.
Reliability is everything.
So how does XtraMCP keep the agents grounded?
It enforces these pedantic-based schemas and really strict internal consistency checks. So if an agent tries to output something that doesn't fit the schema, like a citation that's formatted wrong, it gets flagged and corrected before it ever gets to the user.
It prevents the LLM from going rogue on you.
Essentially, yes. And on top of this protocol, they built 4 specialized agents: the reviewer, the enhancer, the scoring agent, and the researcher.
It sounds like they're treating the document like it's being submitted to a conference.
That's a great analogy. They explicitly say the AI review pipeline is inspired by conference workflows, like KAI. It forces the AI to use structured criteria.
And these agents are backed by a couple of other specific tech components. One is a low-latency embedding and an LLM re-ranking pipeline. That's for the literature search.
Correct, for high-quality semantic retrieval. And the third component is something called XtraGPT.
Which isn't just standard GPT.
No, it's their own model suite that's been specifically tuned for academic writing style.
How does that tuning actually translate to a better result for me, the user?
It makes sure the revisions are, context-aware and phrased correctly. Instead of getting conversational text, XtraGPT gives you a formal tone, the right technical vocabulary, and accurate formatting for things like equations or citations.
So the patch it generates can be applied instantly without you having to go back and clean it up manually.
That's the goal.
Okay, now we get to see all these complex parts in action. The sources give us 2 really concrete scenarios that show how the system handles both the small stuff and the really big, complex tasks.
Let's start small. The micro-level task.
Yeah.
In-editor editing and patching.
So imagine you're an author. You highlight a section title that's just way too long, something like PaperDebugger, a Kubernetes native agentic system for integrated academic writing assistance.
A classic academic mouthful.
Right. And you ask for a shorter, more structured rewrite.
That one request kicks off the whole pipeline. First, a critique agent analyzes the title for being too wordy. Then an enhancer agent generates new suggestions. And finally, a patch generator formats the output as a clean edit.
And the really critical UI improvement here is that the results come back as before and after diffs right in the side panel.
So you can see the rationale, you can look at the options, and then just apply the one you want with a single click.
This is the behavioral change. It completely gets rid of that old copy-paste pattern and turns editing into this transparent agentic workflow. You get efficiency, but you keep total control.
Absolutely.
Okay, so that's the line level stuff. But now the macro level, deep research and comparative analysis. This is where that researcher agent really shines.
This one is aimed squarely at the pain of writing a related work section.
Oh, the worst part of any paper.
For sure. So an author just highlights the related work heading and asks for deep research.
And PaperDebugger fires up that multi-stage semantic search over huge libraries like Archive.
And what you get back is a ranked list of relevant papers. But it's not just a list. You get the metadata, the abstracts, and an LLM-generated explanation of why each paper is relevant to your work.
But the killer feature, the one that really transforms the workflow, is the Compare My Work tool.
This is the magic. Instead of you having to manually read 2 full papers, compare their methods, and synthesize it all
The system does it for you.
instantly. You select a paper from the list, and PaperDebugger automatically pulls out the key comparative points from both papers. The goals, the data sets, the methods, limitations, everything.
And it generates a side-by-side comparison table.
A structured table and a citation-ready summary table you can insert directly into your LaTeX document. It turns hours of synthesis into an immediate structured insight.
Wow.
And it even goes one step further. The system also generates takeaways for positioning your work.
So it's not just summarizing, it's giving you strategy.
It's helping you articulate exactly how your paper fits into the bigger research landscape, where you're innovating, and what limitations you're addressing. It's strategic insight tied directly to the document you're writing.
Incredible. But to validate that a system this complex actually works in the real world.
Right, in the high-stakes world of academic publishing. The researchers looked at 6 months of anonymized telemetry from May to November 2025.
So let's look at the adoption numbers because this is the proof of sustained use. They had 112 Chrome extension installs and 78 registered users. But the key number for me was 23 monthly active users.
That 23 MAU figure, it points to roughly 30% retention. And that shows that this wasn't just a toy people tried once. They were integrating it into their actual multi-session projects.
Yeah, the numbers back that up. 158 projects and 797 writing threads in just 6 months.
That's strong evidence of consistent use over time. And while the user feedback was mostly positive, people loved the seamless and convenient workflow, they did get some really useful critiques.
Yeah, what were the main complaints?
Some users saw performance drops on really long documents, which suggests the Kubernetes scaling could be optimized further. And some mentioned the tone, that suggestions could sometimes sound a bit CS-like, a little robotic.
Which is great feedback for tuning extra GPT.
Exactly.
But the most important piece of data for me confirms how people are using the core innovation, that patch mechanism. The telemetry broke down the 3 most common actions.
And the number one action, by a huge margin, was diff viewed. It happened 1,073 times.
1,000 times.
Then you had copy suggestion at 375 and insert patch at 359.
The fact that diff viewed is the dominant interaction is almost triple the number of times a patch was actually applied. That validates the whole design philosophy, doesn't it?
It really does. It proves users are not blindly accepting the AI's output. They're actively inspecting the changes, they're reviewing the rationale, and they're making a critical, informed choice before they commit to a change.
They're using the system to guide their thinking, not to replace it.
Right. They're iterating and revising, and the user keeps the final agency over the document.
So what does this all mean for the future of professional writing? I mean, PaperDebugger successfully closes that technical and UX gap by moving the intelligence right into the source environment.
And that tight integration enables all of it, the context-aware critique, the deep retrieval, and that deterministic traceable editing with the single-click patches.
It feels like a fundamental shift.
It is a shift from external tools to these fully integrated agentic systems. It ensures that knowledge, whether it's from an AI critique or from the literature, is instantly understood and applied in context without breaking the writer's flow.
And as the analytics showed, the system's success really depends on the user actively inspecting those changes. We saw it right there in the data. Researchers viewed over 1,000 diffs before applying about 360 patches.
Which leads us to a really powerful final thought for you, the listener.
Let's hear it.
If we continue to embed these powerful, sophisticated AI agents directly into our primary creative and scholarly tools, How does the ability to reject an automated suggestion, to critically analyze that diff line, become just as important, or maybe even more important, than the ability to just click Insert?
The intelligence might be automated?
But the critical thinking still rests squarely with the author.
Food for thought. It changes the role of the writer from just a generator to the editor-in-chief of a powerful team of AI agents. That's all the time we have for this deep dive. We'll see you next time.